Who is Democritus and Leucippus? Leucippus and Democritus are widely regarded as the first atomists in the Greek tradition. Little is known about Leucippus, while ideas of his student Democritus, who is said to have taken over and systemized his teacher theory, are known from a large number of reports.
What does the Greek word atomos means? The Greek word atomos means not able to be divided or indivisible.
What did Democritus and Leucippus propose about the atom? Atoms are small hard particles, made of a simple material that's formed into different shapes and sizes. They're always moving. They're formed different materials by joining together. Yeet.
What is an atom? An atom is the smallest particle that an element can be divided and still be that element.
John Dalton. 2,000 years later, a British chemist and school teacher brings back Democritus' idea of the atom. He performed many experiments to study how elements join together to form new substances. He found that they combine in specific ratios, and he supposed it was because the elements are made of atoms.
What three new ideas did John Dalton propose about the atom? All substances are made up of atoms, which are small particles that cannot be created, divided, or destroyed. Atoms of the same element are exactly alike, and atoms of different elements are different. Atoms join with other atoms to form different substances.
J. Thomson, 1856 to 1940. What particle did Thomson discover? J. Thomson discovered that atoms are made of smaller negatively charged particles called electrons using a cathode ray tube. The plum pudding model. Thomson didn't know how the electrons in an atom were arranged. He believed that they were mixed throughout an atom. He proposed that the atom was a sphere of positively charged material. Spread throughout the atom were the negatively charged electrons, similar to plums in a pudding or chocolate chips in an ice cream.
Ernest Rutherford was a student of J. Thomson but disagreed with the plum pudding model, devised an experiment to investigate the structure of positive and negative charges in the atom.
Gold-foiled experiment. What did most of the particles shot at the gold foil do? Most of the particles traveled straight through the gold foil. What was the surprising behavior at a few of the particles? A few of the particles were deflected and some even bounced back.
Niels Bohr, early 1900s, is a Danish physicist. He proposed a model of the atom that is similar to the model of the solar system. The electrons go around the nucleus like planets orbit around the sun. All electrons have their energy level.
Energy levels. Each energy level can hold a certain number of electrons. Level 1 can hold 2 electrons. Level 2 can hold 8 electrons. Level 3 can hold 18 electrons, and level 4 can hold 32 electrons.
Energy levels. The energy of the electrons goes up from level 1 to the other levels. When electrons release/lose energy, they go down a level. When electrons absorb/gain energy, they go to a higher level.
Quantum mechanical model of the atom. There are different kinds of atomic orbitals that differ in the amount of energy and shapes where the electron probably is. The quantum mechanical model views an electron as a cloud of negative charge having a certain geometrical shape.
Three physicists led the development of a better model of the atom: Louis de Broglie, Erwin Schrödinger, Werner Karl Heisenberg.
Louis de Broglie was a French physicist who made groundbreaking contributions to quantum theory. Proposed that the electron could also be thought of as a wave. Erwin Schrödinger was a Nobel Prize-winning Austrian physicist who developed a number of fundamental results in the field of quantum theory. Developed a mathematical equation to describe the hydrogen atom. Werner Karl Heisenberg was a German theoretical physicist and one of the key pioneers of quantum mechanics. He published his work in 1925 in a breakthrough paper. Discovered that for a very small particle like the electron, its location cannot be exactly known and how it is moving. This is called the uncertainty principle.
Principle of electron configuration. Aufbau buildup principle. Electrons will successively occupy the available orbitals in order of increasing energy.
Principles of electron configuration. Hund's rule of multiplicity. Electrons entering a sublevel containing more than one orbital will spread out over the available orbitals with their spins in the same direction before they pair up with the opposite spins.
Pauli exclusion principle states that no two electrons in an atom has the same four quantum numbers. The four quantum numbers. The first quantum number is the principal quantum number designated by the letter n. It defines the total energy of the electron. The second quantum number is designated by the letter L. It describes the way the electron moves around the nucleus or the shape of the probability distribution.
The third quantum number is the magnetic quantum number designated by ML. It defines the possible orientation of the electrons in space. The fourth quantum number is the spin quantum number designated by MS. It takes into account the spinning of the electron around its own axis as it moves about the nucleus.